cladogram is a graphical representation of the hypothetical relationship between different groups of organisms. It's used to determine the evolutionary relationship between them and how groups of organisms are related to each other by comparing the morphological structure. The more morphological structure is shared, the closer is the relationship. Meaning to say in cladogram, the closer the fork in branch between the organism, the closer is their relationship. A phylogenetic tree is given an actual representation of the evolutionary history of the organisms. However, a cladogram gives a hypothetical picture of the evolutionary history of the organisms. They are used to determine the evolutionary relationship between the different groups of organisms by comparing the morphological structure of the organism. Corresponding body parts they are alike in basic structure and origin are said to be homologous structures, and the organisms that share a large number of homologous structures may imply that they are related to each other. Different groups that share derived characters can be linked together in a cladogram. The more derived characters are being shared by groups of organisms, the closer are their evolutionary relationship. Meaning to say that in the cladogram, the closer the fork in branch between two organisms, the closer is their relationship.
The objective of this task is to construct a cladogram by using a set of hypothetical organisms called caminicles. For procedure, examine the 8 different caminicles based on the characteristic given. Second is we need to determine which characteristic of each organism has. Then, in the table below, place a plus symbol in the box if the organism have the characteristic. The final step is to draw a cladogram showing the hypothetical evolutionary relationship of the caminicles.
Hi guys, this is the list of caminicles, which is a set of hypothetical organisms. As you can see there is 8 organisms. Basically, these are the characteristics that we need to identify to describe the caminicles. So for character A, which is I present with positive sign versus I absent and negative sign. So character B, body mental present, positive sign, and body mental absent, negative sign. Meanwhile, for character C, paired non-jointed anterior appendage present versus paired non-jointed anterior appendage absent. So character D, anterior appendages flipper-like versus anterior appendages not flipper-like. Character E, eye stalk versus eyes not stalk. And character F, posterior body mental bulbous versus posterior body mental not bulbous. Character G, eyes fused into one versus eyes separated. Last but not least, character H, forelimbs with digits versus forelimbs without digits. So let us focus on character A first, which is I present versus I absent. So what we need to do is, we need to look at the caminicles, which they have 8 organisms. So we need to identify whether the I is present or absent. So refer to the caminicles. So for character B, which is body mental present, all of them have the body mental. For character C, which is paired non-jointed anterior appendage present, which we label as positive sign, on the organism 1, 2, 4, 6, 7, and 8 have it. And for character D, which is anterior appendage flipper-like, character D, only organism 2 and 7 have it. Okay, for character E, I stalk versus I not stalk, only organism 2 and 7 have it. So character F, which is posterior body mental bulbous, okay, only organism 1, 4, and 6 have it. Okay, and for character G, which is eyes fused into one versus eyes separated, only character G have eyes fused into one. Meanwhile, for character H, forelimbs with digits versus forelimbs without digits, only organism 3 and 5 have it. After we have done with the data table, then we can proceed with construction of cladogram.
Today I'm going to explain about our group prepared cladogram. First, draw a straight line. This line is the common ancestral trait shared by character A and B. So here I am marking A and B. Then look for the third most common character shared by organism, which is C. Draw a branch for character C from common ancestral line, that is A and B. Here I am marking it as C. Label organism 8 at the end of branch C, as organism 8 only share character of A, B and C. Draw a branch from branch C for character F. Here I am marking it as F. Organism 1, 4 and 6 shares common traits of F. However, only organism 1 share characters of G and F. Draw a branch from character F for organism 4 and 6. Label G for organism 1 at the other end. Draw another line distal to the first branch from C. Label branch as characteristics D and E for organism 2 and 7. Organism 3 and 5 only has character H beside the common ancestral characteristics of A and B. Therefore, label organism 3 and 5 via a branch at the end of the common ancestral line with the label H after the branch of C. Therefore, to summarize, organism 3 and 5 has characteristics A, B and H. Organism 1 have the characteristics of A, B, C, F and G. Organism 4 and 6 have the characteristics of A, B, C and F. And organism 2 and 7 has the characteristics of A, B, C, D and E. Lastly, organism 8 has the characteristics of A, B and C. Thank you.
So for the first question, which of the features are considered ancestral? So what we have come out with the results is, in our example given in the constructing cladogram for laboratory session, is for character A and B is the same in all 8 ATUs that given. So these two characters are primitive to the entire group. That means primitive characters are not informative for separating OTUs into unique taxa. So that is for the features that are considered as ancestral for character A and B. So for question number 2, based on the Caminacus morphology, suggest 2 other characters that also can be used to distinguish the species. What I have found out from our example is about 3 characters that I want to share with all of you. So we go to character E. Character E is shared only by OTUs 2 and 7. Okay, for character F is shared only by OTUs 1, 4 and 6. Character H is shared only by OTUs 3 and 5. So far for the inference that I can give you guys an explanation for it is, character E was inherited by OTUs 2 and 7 from a common ancestor. So for character F was inherited by OTUs 1, 4 and 6 from a common ancestor too. Lastly is for character H. Character H was inherited by OTUs 3 and 5 from a common ancestor. So a cladogram consistent with the distribution of these 8 characters among the OTUs have been shown in the sketching figure that you already see before this. Okay, so I will explain more about the pros and cons of comparative morphology analysis. So basically, what are the pros and cons for the morphological analysis? So it is to determining the morphological phylogenetic hypothesis actually. So for the pros, at first is quite cheap. It is compared to the disadvantages that is we can find such a fewer characters in it. So second is the pros or advantages of the morphological analysis. Okay, comparative morphological analysis is we can find available there are many available samples. That means many genetics that we can find out on it to determine the phylogenetic hypothesis. So it is many genetics that we can find out on it. Okay, for the cons or disadvantages is the environmental effects or effects on the traits obscure. Okay, So next is the advantages or pros that we can find in the morphological comparative morphological analysis is it can include the fossil stool. So it is compared to the disadvantages of the morphological data or morphological analysis is we not really sure of homology all the time. So last but not least, for the pros and cons between the morphological analysis to determining the phylogenetic morphology hypothesis is developmental charts. That is for the advantages. We can find the developmental charts, but we have the difficulty to find the inter-investigator variation in the trait coding.
I just keep upset